Hi, my name is Muhammad Alif. I'm from University Kuala Lumpur Malaysian Institute of Industrial Technology. Today, I would like to present my project entitled The Development of Smart Shaded Plant House with IoT. For the introduction, the growth of the human population, particularly in large cities, has a direct impact on food availability. To fulfill increased customer demand, farmers must boost vegetable and fruit production while maintaining food quality. With the increase in human population, it will result in limited places or areas for agricultural activities. This situation becomes more critical when some types of crops need a certain environment to grow faster and healthier. This includes the cultivation of plants that require a specific climate and lower temperatures for planting. Without the right environmental conditions, plants cannot grow healthily and may die. In Malaysia, crops that require high humidity and low temperature will only be planted in certain places, such as in Cameron Highlands, which involve the cultivation of tomatoes, strawberries, corn, and others. Such crops can grow well and fresh and will usually be sold at a relatively high price compared to crops grown elsewhere. On the other hand, farmers have invented several additional options, including the rapid construction of greenhouses with the ability to grow fresh crops. A greenhouse provides a longer growth season because the greenhouse provides a more regulated environment for growing. Plants will not be harmed by temperature swings, whether they occur at the start or end of the planting season. Greenhouses also protect plants from the effects of extreme weather. If sensitive plants are not protected, even strong winds or bright sun rays might harm them. Sunlight is dispersed under a translucent canopy and adequate ventilation is provided throughout. In this study, a system was designed utilizing Arduino as a microcontroller by automatically adjusting factors like temperature, soil humidity, and the number of UVs that penetrate the greenhouse and monitoring it via the internet using a smartphone. For the literature review, we know that Malaysia is hot and humid climate throughout the year. Tomato agriculture is mostly centered on cooler upland places such as Cameron Highlands in Pahang and Kundasang, Sabah. The tomato plant's growth is influenced by the amount of moisture in the soil. Plants absorb sunlight through their cells, which include chlorophyll, to perform photosynthesis, which converts light energy into chemical energy to produce their own food. In this project, several parameters is controlled. The first parameter is the temperature. The Arduino Mega is utilized as a microcontroller in this project to control the entire system. The Arduino will activate the Peltier module to lower the temperature and cool the environment in the prototype if the temperature in the prototype reach the maximum of 24 degrees Celsius, and switch it off if the sensor detects a minimum temperature of 18 degrees Celsius. This monitoring system can also be viewed and operated from a remote location and may be accessed via the smartphone using the Blink application. The second parameter is soil moisture. When the sensor detects that the soil moisture level is less than 55%, the Arduino will turn on the water pump. And when the soil moisture level reaches the expected value of 65%, the Arduino will turn off the water pump. The third parameter is the ultraviolet rays. When the UV sensor detects ultraviolet light greater than 290 nanometer, Arduino will activate the switchable glass to turn on, making it thick. And when the UV sensor detects the ultraviolet light less than 280 nanometer, Arduino will trigger the switchable glass to turn off, making it transparent. This is the design of our project. In this project, we use the HT11 sensor to detect humidity and temperature, UV sensor to detect the amount of the UV rays, and soil moisture sensor. For the results and discussion, the first parameter is the temperature control. When the temperature inside the smart shaded plant house falls between 18 degrees Celsius, the thermoelectric pellet will switch off. And when the temperature rises about 24 degrees Celsius, the thermoelectric pellet will turn on. As a result, the temperature can be controlled efficiently and accurately. This cycle will be repeated indefinitely to keep the temperature in the smart shaded plant house between 18 degrees Celsius to 24 degrees Celsius. For the result for the humidity control from this graph, we know that the ideal percentage for humidity conditions is between 55% to 80%. The humidity level was consistent on the day of the experiment. Humidity is related to temperature, which implies that when the temperature is low, the humidity is high, and vice versa, when the temperature is high, the humidity will be low. The third result is soil moisture control. For the soil moisture is measured with the 5-volt YL69 soil moisture sensor. To maintain plant growth without harming the roots, the soil of tomato plants required 55% to 80% moisture in this situation. The third result is the ultraviolet control. The ultraviolet reading in the greenhouse on that day began to rise at 5 a.m. as the sun began to rise and illuminate the greenhouse. This scenario will cause smart shaded to function and shade the greenhouse tomato plants. When there is no ultraviolet radiation present in the evening that can harm tomato plants, smart shaded will deactivate and become transparent. And the last result is about the average height for tomato trees. The average height of tomato trees after a few weeks can be monitored, can be seen from this graph. Based on this graph, tomato plants that use the smart shaded plant house system have faster growth than tomato plants grown with conventional methods without using the proposed greenhouse system. The development of the smart shaded plant house with IoT can be summarized as follows. From the experimental result, it shows that the smart shaded plant house has been fully tested where all the hardware and software system can work well and efficiently. The proposed smart shaded plant house system can monitor and maintain parameters including temperature, humidity, soil moisture, and UV levels. The closed structure of the smart shaded plant house can prevent any pests from entering and damaging the tomato crop. This closed structure can also protect plants from strong winds and unpredictable weather that will interfere with the growth of tomato plants. And corresponding with the fourth industrial revolution IR 4.0, the proposed greenhouse system will make it easier for farmers to automate the process of growing tomatoes and obtain a high and fresh harvest without having to be constantly in the greenhouse. Thank you for your time.